Hi, we present what changed and what could have changed. State change counterfactuals for procedure-aware video representation learning. Understanding human daily activities such as cooking, furniture assembly, or ultimately building intelligent and collaborative agents that can understand how and why humans perform actions in daily life. This requires understanding how actions cause changes in a scene. For example, recognizing that slicing an apple changed the state from being intact to being sliced. Additionally, they require the ability to reason about what could have changed if action steps were not executed correctly. That is counterfactual reasoning. Existing work on learning procedure-aware representation often relies on associating video features with text features extract from narrations. More recent work further models the temporal order of action steps to learn procedural structures. Yet they often struggle to explicitly model how things evolve over time and perhaps more importantly, how they could have evolved under different conditions. For example, what would happen if slicing an apple did not go well? This limitation can lead to overfitting on scene and successful activities, thereby hindering causal reasoning. To this end, we propose to explicitly use state changes and their counterfactuals as learning signals. We leverage a large language model, Llama 3, to generate these textual descriptions, specifically given a short sequence of frames, which we refer to as a clip, and its corresponding narration provided by Eagle4D. We prompt Llama to generate diverse before and after stats that describe the changes induced by an action. Next, we prompt Llama to generate state change counterfactuals by asking it to imagine what-if scenarios. For example, what if the oatmeal spilled onto your desk? What would have happened? To further extend state change counterfactuals from the short clip level to the more global video level, each composed of multiple clips, we fed Llama with a sequence of short clips narrations that together compose a complete video. We asked it to generate missing step counterfactuals by removing key steps from the sequence and producing text that describes what would happen in such counterfactual scenarios. Moreover, we also asked it to shuffle the order of key steps to generate misordered counterfactuals that result in failure activities. To leverage state change and their counterfactuals, we propose a hierarchical video text mapping framework that extends upon the existing hierarchical framework. First, we apply temporal contrastive learning at the frame level to bring nearby frame features closer and push distant ones apart, enabling the model to capture the progression of actions. We then incorporate before and after stats into the temporal contrastive laws, using them as positive pairs with their corresponding frame features and as negative pairs with the upside state frames. Furthermore, to enable clip-level counterfactual reasoning, we incorporate state change counterfactuals as negative examples in the learning objective. At clip level, we perform conventional clip-to-narration alignment using contrastive learning. Lastly, we extend the counterfactual reasoning at video level by contrasting the whole video features with the video summaries annotated by Eagle4D as positive pairs, and with the key step and misordered counterfactuals as negative pairs. To demonstrate our model's procedural awareness, we first benchmark it on two long-term procedural tasks, temporal action estimation and unsupervised error detection. In temporal action estimation, our approach outperforms existing video encoders, procedure-aware representation methods, and even the VO and higher VO on most metrics. In unsupervised error detection, where no abnormal data are seen during training, our model achieves state-of-the-art performance on most metrics, demonstrating the effectiveness of state changes and their counterfactuals for understanding procedures. We also conduct experiments on short-term procedural tasks, including action recognition and action phase recognition and retrieval. And our approach demonstrates its value in short-term procedures by showing the state-of-the-art performance on these two tasks. Thank you, and please check our paper for more details.